Hello, my name is Tanner Collins. I'm a flight simulator technician here at Fly-Rite, and this is our Dash 8 full flight simulator. So this simulator was built in the late 80s and early 90s, and I began training probably in 91 or so. And as a result, it ran off the best computers that they could get at the time. And so here we have, this is our host computer. It's a IBM Power Server 530, and it runs most of everything in the simulator. All the instruments, flight controls, motion, everything. And these two are Silicon Graphics Personal Iris 4D25s, both of them, and they run the instructor's operating station that the instructor would use to reposition the airplane and put in malfunctions and all sorts of stuff like that. So here we got our host terminal here. It's where I would start the simulator program. I'll show you an example of that. Let's see. So it's run through this, and all the software on this thing is proprietary. It's all, this simulator was made by CAE. I think it stands for Canadian Aviation Electronics, something like that. But all their software is proprietary. All their electronic boards are proprietary. I'm about to show you that in a second. But, so basically, to load it, just type in 300. Because this simulator is built as a Dash 8 100 and a Dash 8 300. We always train it in the 300 because that's what all our clients ask for. So it's just running, doing the load up sequence. And this is a spare iris I've been working on. This is my Raspberry Pi that I made, and he does a lot of things. Initially, I wanted to replace these old terminals because they are expensive, and I'm trying to get a replacement or something. So I wanted to find a cost-effective, modern solution, and I did. Basically, uses a MAX 3232 chip. And to convert the serial to the level that the Raspberry Pi uses. It's got everything oriented on this hat here, so I can solder it all together. Those two switches you see actually swap transmit and receive. They're meant to be moved together. I just didn't have the right switches at the time. And the two transistors actually they actuate the loopback handshaking. So in the software that I made for the thing, well, not software, the script that I made for the thing, when it kills a screen, which is the application it uses to talk to it through serial, it will break the loopback handshaking connection to make the host computer think that you've turned the terminal off, so that when you kill it, it will come right back to the login screen. I wanted it to emulate everything that these terminals did. Sometimes we gotta turn them off and turn them back on. We always start up on the login screen, so I wanted to do that. Raspberry Pi talking to a very, very old computer. And it works. It seems that this host computer really likes VT220s, so thankfully Screen will emulate that and find, select, previous and next page. They all work. I'm not 100% sure about them PF buttons. I haven't really used them too much. You mainly use those in the editing software, but let's see here. We got two hard drives running the host computer here. Let's see. And then our our two Irises here. Like I said, they run the instructor's operating station, which I'll show you here in a second. They take their 3 B&Cs from the back. We can see there, red, green, and blue. And they run them about 75 to 100 feet up to the simulator in there. There's our 16-port splitter for the host computer, and isolation boxes. There they are. There's one of them. The newest computers that you will find on this thing are right here. This is the visual system here. It used to have a lot older computers on it, and it ran proprietary boards for pixel processing, texture processing, stuff like that. Ran off really, really big projectors, had multiple lamps each. Now it just runs off of this here. There are 6 projectors you can see up there. Those, I think you can only see 2 right now, but there's 6 mirror arrays in there, and they make up the image that you see out in front of the cockpit. So, but yeah, these were this was done in 2012, and they run off GTX 580s. The host computer, it doesn't run all the instruments and stuff directly. It actually runs all these blue cabinets here, and I'll show you. So you've got 4 Ethernet transceivers here, and that corresponds to each one of these buckets. Now behind these covers here, big racks of cards. One card controls the communication with the host computer, and all the other ones do various things wherever it needs to do. It seems to me, you can't quite see, it's kind of dark. This, all these, every single one of these is a digital out board. Takes a 28-volt signal and runs it through all these little relays, Mercury read relays. And these are those proprietary boards I was talking about, all made by CAE. They still use them to this day. Here's our DM1 cabinet. It controls the motion and the controls as well. Runs an EL screen, probably made by Finlux or Planar or something like that. We got our hydraulic pump room, that big metal room over there. You get to it from beyond those stairs there, just right across right toward the wall. And yeah, motors on here. Simulator runs off of the oil is not warm, therefore throws a failure, and that's something that'll happen until the oil warms up. So we'll get you a shot of the back here. That's where all the cards plug into. This is the back of one of those buses. You can see there's a lot of wire wrap there. The common ground and 5-volt lines there, as well as 28-volt. There's another one. Power supply in there. A little dark. Lambda power supplies, a ton of them. You can see there's a replacement for one right there. anytime something crazy happens with this sim and it's not working right, more than likely a power supply has gone bad somewhere. We gotta figure out which one it was, and that can take quite a while. But as long as you keep these things on, they're fine. If you turn them off, that's when things start going bad. Looks like a duck, quacks like a duck, you know, flies like a duck, everything. That's what they went by to make it one-to-one with the, to make it as close to one-to-one as possible to the real thing. And so this is a level C simulator here. According to the FAA, that means it's approved for certain types of training. So here we are inside the cabin here. Cockpit's dark, visuals aren't up. And we have loaded the simulator, but we haven't run it yet. So I type in SimX, which stands for Simulator Executable. All right, run. There it is. You can see everything light up here quite a few times until it starts. We know it starts because flight free is right there. Well, first off, it loses its box, and then it will regain its box, and it will be colored in completely orange. So that's how we know it's done. Very dark. Can't see nothing there. Let's see here. One thing I didn't check downstairs was whether the visuals were loaded or not. That's done on the visual server computer. So while that's going on, these right here are the instructor's operating station I was talking about. You can see you could change all sorts of stuff, lighting, time of day, weather, which is really fun, your airport. You can reposition the airplane to on the runway, at the gate, whatever you need. The ATIS. We also run our tests here. I call them QTGs, Qualification Test Guide, I believe is what it is. And run it through here. And as I said, these are run, these iOS stations are running on the SGI personal irises. So they're a little old, runs on 3.3.1, I believe, version of IRIX. The visuals are up, coming up one at a time here. And I'll blink a little bit. One of the issues we have with the particular projectors that we use is the projector optical block likes to yellow. And that's very apparent right in this one. This is our worst one here, and we got to send them off to get repaired, to get them replaced. So some are better than others. You can see the colors off on just about all of them. All these, the whole iOS application was made on a proprietary program that they got called GE. And that stands for, get this, Graphics Editor. Yeah. So all the functions, like when you press a button, it'll go to a new page. All that stuff set up through there. And I actually ended up making this startup screen here for us. We'd been wanting to do it for quite a while. It used to say US Air, which is who we bought it from. We bought the simulator from. Due to this thing being so old and our limited documentation we got, and software, we don't have all the software for these things that we need, just enough to run it. You just touch it, and there it comes. Comes up with the map. We're at KCLT. Yeah. And the thing runs pretty good. A lot of questions I get, why don't you update to modern computers. Well, if we did that, for one, it would cost a lot of money, and there would have to be some sort of ability that we would gain to make money if we invested in that. So it runs pretty fine right now. Let me turn the cockpit on here. These parts are old, and not a lot of people have them anymore. If we lose an instrument, we pretty much got to go on eBay, because one thing about the aviation industry is parts are very expensive because they have to be certified for airworthiness, and that comes with a cost. So we don't have to worry about that, being a simulator shop. So we can open these things up and work on them and do what we need to do. These aviation electronics can get pretty complex sometimes, but we do all right. They're built very well too, so they don't go bad often. The main things we change are light bulbs. You can see up there. This thing's close to 30 years old at this point, so there's some discoloration going on. Things are burnt out. Well, the lights aren't burnt out, and you can see permanent heat discoloration there. Yeah. Paint's chipped. Things are worn, like that park and brake handle there. Very worn. It's got character. That's what they would say. Okay, so here's part 3 of my little tour here. We're going into a turn, about to come in for a landing. So one of the biggest parts of my job as a simulator technician is to, before any training happens, I have to come in here and I have to pre-fly the sim. And what that entails is making sure that everything is working as intended, nothing's wrong, no light bulbs are burnt out, and also wiping down the sim. I got my Clorox wipe here, and it's always been a big part, but especially nowadays with COVID and everything, I gotta really make sure that I wipe down every surface. So a big question that I get asked about working this job, well, as a byproduct of this job, I learned how to quote-unquote fly a quote-unquote plane. I've never flown a real plane. I've only ridden in a real plane just a few times. And let's see, we're a little high here. Let me put this down here. Bring the speed down. Vertical speed down. You catch the glide slope there. Really bring my engines back because I'm going just a bit fast. Actually, no, I'm not anymore. Alright, now this is what you would call a very steep approach. In fact, most pilots would not attempt to land this. Due to time, though, I probably will. Now, need to do a few things. I don't know, it's getting a little hairy here. Let's see. I can probably do it. Might have to make a spin here. It's hard to do it with one hand, though, is the only thing. So let's see. Let me take a turn. Make sure that I don't go under speed and fall out of the sky. Keep the yoke up with my knees so I can push the engines up a little bit. And I'm still losing a bit of altitude, or a little bit of airspeed. I'm sorry. I want to lose altitude. The airspeed I want to keep. This is pretty good airspeed right here. As long as I don't dip too far under this, end up stalling out, crashing. But yeah, so people ask me all the time if I could land a real plane, and to be honest, I probably could. Through the 2 years I've been working here, I started when I was 23, I'm 25 now. 2 years I've been working here, I have, as a byproduct of me doing these pre-flights, I've accrued hundreds of hours across the 5 sims that we have, and I've completed hundreds of landings successfully.
Minimums.
I've
Too low. Flaps.
I haven't really
Too low.
crashed
Flaps.
them too many times, believe it or
Too
not.
low. Flaps.
But the hardest part
Too low.
about flying
Flaps. Too low.
is
Flaps.
not the maneuvering of the plane,
30,
I don't think.
20.
There we go.
10.
Yeah, there we go. It's not the maneuvering of the plane, it's really the what to do in emergency situations, like if you got an engine out. Flying when you can't see out the window. Just flying by your instruments, navigating that way. That's the real hard stuff. Knowing all the different speeds that you should that you will stall out in, because it's not just going too slow. You can stall out a specific wing or a specific control surface, and you stall out a wing, you'll spectacularly spin to the ground. So that's the scary stuff, and that's stuff I don't know. But as long as you keep it going pretty fast, you're all right. But anyways, so yeah, I could probably land a plane if I had to. I hope I'm never in that situation. But if I had to, I'd definitely try. But anyways, so one of the biggest things about simulators is what's genuine and what is simulated, right? So in terms of avionics, we have genuine avionics in here. Most of the main ones, like this ADI and this HSI, I might have got those backwards, but vertical speed indicator right here, the altimeter, airspeed over there. Those are probably all real, genuine instruments driven by real, genuine flight computers that are fed simulated data. So I know this panel here is real. This one here is not. Oh, this one here is not. Any pneumatically driven instruments, as well as this one here, this is a simulated instrument. So is this. The wet compass here has got to be simulated, because I'm not actually moving around, you know. I'm not actually facing north, faces the same direction. That guy there, that slip ball in there, that's usually just a ball and some fluid, but our sims have motion, but so you can feel the G-force when you take off, a simulated G-force, probably not one-to-one, but anyways, yeah, some instruments are stimulated and some are simulated, so there's that distinction there. All these engine gauges here are genuine. These computers here, or well, the FMS here and the weather radar, those are genuine. Yeah, so the control panel there, the autopilot control panel, is a genuine instrument. Most of our comms down here, all genuine. And that's our vintage flight simulator here at Fly-Rite in Concord, North Carolina. Thank you.